Hello guys, I am going to introduce to you the three types of motion. And the first types of motion is translational motion, and the second is projectile motion, and the third is circular motion.
Today topic: translational motion. Firstly, we need talk about what exactly motion is. Motion is one of the key topics in physics.
Translational motion, when an object moves from one place to other place with respect to the frame reference. Then this motion is said to be translational motion. For example,
Place around us like a book falling. Bus moving. It might only be a small amount of movement. And very slow. But movement does happen.
and we are going to tackle little about the second motion, which is projectile motion. The definition of projectile motion is the motion of unthrown or projected into the air, subject the only acceleration of gravity. The object is called projectile and its path is trajectory. Example, tossing an object into the beam or water flowing from a tap or jumping from a bus. Projectile motion. When we talk about motion, most people think of straight line motion like a toy car traveling across a table. But motion also includes objects that move up down vertical motion. First, a force is applied upward, but the force's gravity immediately begin to accelerate downward. So that give us two types of motion, horizontal and vertical. But real life isn't always that simple often. These two motions are combined. When an object moves both horizontally and vertically, it is called projectile motion. Think of it like this. We want to get the socks from the folding table into the laundry basket. If we just tried horizontal motion while they are distance to reach the basket, gravity pulls the socks down to the ground. If we try just vertical motion while the socks have the height to reach the basket, they don't travel towards the basket. But if we horizontal and vertically, the socks have both the distance to reach the basket and the height to compensate for gravity. That is projectile motion. But projectile motion has many uses beyond just putting away laundry, from plotting airplane flights to playing sports to rocket science. Projectile motion is an essential part of our lives. Projectile motion when an object undergoes both horizontally and vertically movement.
Object learning this type of motion is very important. Here are a few terms that we'll encounter later for a better understanding of our topic. Let us first define these terms. First, we have the word force. Force, a push or pull of an object. Next is accelerate. It means to speed up. Then we have velocity. It is the speed of something in a given direction. Next is tangent. It is a straight line that touches but not intersecting a point at a curve. But before we dig deeper to the definition of our topic today, let us clear our minds about the common misconception of a circular motion. People often talk about the centrifugal force, the kind of force that pushes things outward as they move in a circle, but this kind of force does not exist. Always remember that things accelerate inward as they move in a circle. This kind of force is also known as centripetal force. Okay, to explain how things really accelerate when moving circles, let's take this as an example. Suppose you have a rope and a ball hanging off the end of it. You spin it around your head. So how would you describe this kind of motion? Well, first of all, it is moving around a circle. But in any particular time, the actual is moving in a velocity that is tangent to the circle. Suppose this arrow represents the velocity of the ball. You can say that the velocity at this point is always tangent to the circle. Now if the ball continues to turn, then you can say that the velocity changes. As a result, as you know, a velocity is a vector quantity, which means that it has a size in that direction, and this example assumes that the ball is spinning at a constant rate. We also know that the size of a ball is also constant, but since the direction is constantly changing, then we can say that the velocity is also changing. So what does this mean? Well, if a velocity is changing with respect to the time, we say that it is accelerating. And the only reason for something to accelerate is if there is some sort of force acting on it. Now, what is the force? In this case, the force that is causing the object to continually change direction is the force that the person is applying through the string. We can call this force the centripetal force. Let's say we have a force represented by this arrow. The force is pointing towards the center of the circle. Remember that the centripetal force always points to the center. Okay? So as we rotate it around, you can say that the velocity is constantly changing, and so is the force. Take note that not referring to the strength of the force, but rather its direction. As long as the force exerts itself, the velocity continues to change its direction. Another critical thing to consider is the angle between the velocity vector and the force vector. The angle should always be 90 degrees. Now the ball is tied to a string, right? This string is representation of the radius of the circle. All these factors give you the definition of something undergoing circular motion, and that is, an object is moving at a certain velocity and expressing a force that is always right angles directions of the velocity. That is why the object is moving in a circle. Given all of this, the velocity, the force, the radius, and the mass of the ball, we can form a formula. The formula is written like this. Centripetal force is equal to the mass multiplied by the velocity squared over the radius. Since we know that the force is equal to mass times acceleration, then we can conclude that the centripetal acceleration is equal to velocity squared over ages. This means that if we want to increase the centripetal acceleration, we need to increase the velocity. So if you spin the object faster around your head, you're going to have to apply a greater force. Here's a quick trivia. Did you know that an amusement park is also a huge physics classroom? You heard it right. All of these rides in an amusement park are built with the laws of physics and is playing with those laws that make this ride so fun and intense. Okay, going back again to the topic, let's talk about the other factors in uniform circular motion. These other factors are what we call period, frequency, and angular frequency. When an object with constant acceleration is moving around the circle, it will take a certain amount of time to return to its starting point. Starting point that I am referring to is just some point along the circular path. We call this certain amount of time as the period of the motion, and we use the variable to represent it to the unit for the period of time as seconds. But how do we know that how many times the object passes through the starting point at a given time? Well, this is where frequency comes into place. Frequency of a motion is the number of rotations in some unit of time. We write as the variable f to represent, and the unit of the frequency is hertz. We encounter the term angular frequency in uniform circular motion problems. Angular frequency is the rotation rate measured in radians. It is represented by a Greek alphabet called omega, and the unit for angular frequency is radians per second. three quantities are related. You see, angular frequency is equal to 2 pi times 1 over the period, but since frequency is equal to 1 over the period, then we can say that the angular frequency is equal to 2 pi times the frequency, so that's all of it.
I'm going to tackle about the circular motion. Circular motion is a movement of an object along the circumference of a circle or rotation along a circular path. It can be uniform with constant angular rate of rotation and constant speed, or non-uniform with a changing rate of rotation. The rotation around the fixed axis of a three-dimensional body involves the circular motion of its parts. The equations of motion describe the movement of the center of a mass of a body. And circular motion, the distance between the body and a fixed point on the surface remains the same. Examples of circular motion include an artificial satellite orbiting the Earth at a constant height, a ceiling fan blades rotating around the hub, a stone which is tied to a rope and is being swung in circles, and a gear turning inside a mechanism. Since the object's velocity vector is constantly changing direction, the moving object is undergoing acceleration by a centripetal force. In the direction of the center of rotation, without this acceleration, the object would move in a straight line, according to Newton's laws of motion.